Hello there. Welcome back in our lessons in Algebra 1. So today we will discuss the compound inequality. After we have learned how we can solve the linear inequalities, today we will learn how we can combine two inequalities and how we can solve them. Now, the compound inequalities is an inequality as a result of combining two inequalities, join two inequalities by the word and or the word or. Now, when we combine two inequalities by the word and, we get the result, and we call the result as a conjunction, and we combine two inequalities, two simple inequalities by the word or, we call the result as disjunction. Okay, let me explain that by a numerical example to show how these two concepts are different. Let me start. So if I have an equality here, for example, an expression 4x minus 2 is greater than, make it 10, for example. And here I say and, so and I will join this expression by another one, which is 4x, the same inequality, 4x minus 2, but I will put another condition, which is smaller than negative 2. The first, that is possible to be happen. I want to show you that condition. Now, some number greater than 10 and in same time is less than negative 2, that's impossible. So to make the problem is logical and more logical, so I need here to put number is greater than this one. So I will put 12, for example. Now, that's the first thing I want to talk about. Now, let me solve this conjunction statement. This statement is called conjunction. Why? Because it's two simple inequalities related by the word and, joined by the word and. To solve it, it's easy, just solve each inequality alone, each one, solve it. Now you can get back for the previous lesson, which titled by solving inequality. So if I want to solve this, I need to move this negative 2 to other side. So it will be 4x greater than 12. This will become 12, because if I want to move this to the other side, it will be positive. Now 10 plus 2, which equals to 12. Now divide both sides over 4, I will get x greater than 12 over 4, which equals 3. As the interval notion, as we said, we can represent it as from 3 up to infinity. And to know how we can do this, you can revise the lesson which titled by write the inequality, right? And graph the inequality. Good. Now, this inequality in same procedure, I can solve it. I will solve it quickly here. So 4x is this than, this it will be 14. Now x is this than 14 over 4 as a fraction. Now as an interval notion, it means from negative infinity up to 14 over 4. Allow me to put here equal sign to make this bracket just close the bracket. Good. Now, are we finished? No. We still didn't finish the solution here. We need to present the and. We need to know what's the meaning of and here. In set theory, as we learned in sets, properties of sets, and this means this condition and this condition are satisfied together. Both of them are satisfied. So that means I need all the elements which they are common between this one, and this interval and this interval. What's the numbers they are common between them? To find it, it's easy to find it by graph. You need to graph it and find the overlap between two graphs. So if I want to graph it, I will make it the number line. This is the number line. This is 3. I will put 3 here. Now 14 over 4, of course, is bigger than this number 3 because 12 over 4 it will be 3. So it's bigger than 3. It will be something like something here. 14 over 4. Good. Now, what we need to do? From 3 up to infinity, it means from 3 up to infinity. I can graph it like this. Now the second one, from negative infinity up to 14 over 4, and this is a fill circle it will be, and a row directed here to left. Now the overlap between two graphs, it will be, this is one, this is the overlap between here. This is the overlap between these two graphs. So the solution, it will be from 3 up to 14 over 4. And here is open, so I will keep it as open because 3 is not common between them. And here is closed. By this way, we can solve the conjunction problem here, or the compound inequality which used and to join two simple inequalities. Before I move to disjunction case, I want to explain something here in this slide. Now, if I use the transitive property in real numbers, I know the real number has the transitive property. When I say transitive property, I mean if there is a 3 numbers, A and B and C, they are belong to real number, the set of real number, then if A less than B and B less than C, I can rewrite it as B between A and C. You can see that on the number of lines because I said A, this is A, this is B, this is C. Now A is less than B and B is less than C. That satisfies the condition. So B is between C and A. So we can write this conjunction problem in the shortened form as like this. Here for x, -2, this one is between 12, here there is an equal sign here, and 10. So this is another way, the shortened form to represent this inequalities, this conjunction problem. So maybe you will find it like this or find it like this. Now, how we can solve this one? We can rewrite it as the problem and solve it in the same procedure, or easily I can solve it by using the addition inverse and multiplicative inverse. How? To get this one, I need the value of x is restricted where? Is it restricted between two numbers, but what's these numbers? So firstly, I need to cancel this -2 by adding 2 for all of the sides of this inequality, combined inequality. When I say add 2, I mean the additive inverse of -2. So add 2 for all of these sides. This is add 2 here. I want to add 2 for all of the sides. I will get 12 between, this for x is between 12 and 14. Now in same procedure, I can divide both sides over 4 to cancel this 4, or multiply both sides, all of the inequalities by 1 over 4, which is the multiplicative inverse of the coefficient of x here. So I will get 12 over 4, it will be 3 and x is here, and 14 over 4 here. Good. So x is restricted between 3 and 14 over 3. So x is between 14 over 4 and 3. That means, as inequality, as interval notion, it's between is 3 up to 14 over 4. Good. So you have, now we know we can solve this compound inequality which used and to join two simple inequalities by two ways. This is a way, this is another way. Use whatever you want, but you can solve them by two ways. Good. Now let's we go to solve the linear inequality disjunction problems when we use or to combine two simple inequalities. Let me erase the board and get back to you. Okay. Let's we continue. So the disjunction, when we use the word or to combine two simple inequalities, so when we use the word or, what's the difference? What's happened here? There's no a big difference between the first case and another case. I will choose another linear equality like 3x negative 2. For example, is greater than negative 4. And here the word or to relate with another inequality, which is 3x negative 2, which greater than negative 4 or less than negative 6. Good. Now, what I mean by 3x is greater than negative 4 or 3x is less than 6. To solve this, it's same procedure. We can do it directly half. We can solve this one, 3x greater than, I will move this one to the other side, the same procedure, as I do always. It will be negative 2, because it will be a positive here. So x is greater than negative 2 over 3 here. And interval notion is from negative 2 over 3 up to infinity. Now this one, it will become 3x is less than 8. I will move this one to the other side. It will be positive. Now 3x is less than 8 over 3. Sorry, I will divide by 1/3. Now x, as interval notion, it will be between negative infinity up to 8 over 3. Up to now, everything is like the conjunction problem. The same procedure, nothing. But the only difference here in the word, we used or here to join these two simple inequalities. Now, when I say or, we can represent or by the union. Here we can represent it by union. Good. Why union? Because at least one of them must be satisfied, not both of them, like the and problem here, like the and word. So when I say or, it means one of them, at least one of them must satisfy, not necessary to be both. Good. How I can represent this by a graph? If we have negative 2 over 3 here, I can represent it as an arrow directed to right here, and 8 over 3 make it here as directed to here. Now, if I use and, I will take the overlapping here because we search about the intersection of two sets. But here in union, I mean the joint set. So the joint set, it means from negative infinity up to infinity. So the union of this one, the solution set, it will be from negative infinity up to infinity. It means all of the set of real numbers, the set of all real numbers. It's easy to solve some problem like this problem. Otherwise, now, what I have said here. Today we have learned the compounding inequalities. There is two ways to combine two simple inequalities. The first one, which is used a word and, which calls conjunction. The second one, which is disjunction, when we use the word or. And to solve them, just solve every inequality alone and use the union or intersection to find the final solution set which represents the solution set. I hope the lesson is very clear for you. Thank you for your watching. See you in the next lesson, inshallah. Goodbye.